Now in this second video I'm going to show you some things in Social Explorer that we didn't tool around with last time. In mini project number 1 I've already shown you how to download a table. I'm going to return to that and download a couple tables using a slightly different approach, and I'll demonstrate that so that it's something you can do in the final version of this project. But in this video I'm going to talk about a story. The way to think about a story is it's a set of maps, or it's a tool that allows you to create something more like a presentation out of multiple, well, it doesn't have to be multiple, but out of whatever map or maps generate. In this case, I'm going to call this study pop density and commuting. I'm going to look at those two variables. I'm not being particularly specific right now because I haven't committed to any version of a measure yet for either of these. I'm kind of waiting to see what I get. And I'm going to skip this part here where I look at different maps that it thinks I might want to make. I'm just going to say enter, and the name of my project is now pop dense and commuting. I'll just show them somewhere maybe. But you can see here, it's just a map, just like what we got before when we were working with Social Explorer. The difference is it's sort of framed here. So for example, I can add a slide. So if I add a single map, just like I had before, I get exactly the same default view. By default, I'm looking at population density, which, by the way, is why I chose that as one of my measures, so I wouldn't have to change one of the maps. You might want to use two different measures for population density. Now this map, or in the project, I ask you to look at two different measures at the scale of the entire United States. Now to look at two different measures at once in a story, I can create what's called a side-by-side map. So here, on the left, I'm looking at population density, and on the right, if I change the data, I can find, let's say, commute times, if I can spell it. Or I could search commuting, means of work. Let's see about this one. So I want to know how many people spend 60 or more minutes commuting. So that's what I'm going to look at. And I think that's overall, by any mode. It's not breaking it out by any mode in particular. And so I get this map. Now, what you get and what you make of it kind of depends on what your expectations are. In this case, as I was saying before, I can imagine a couple relationships. At the national scale, I would imagine states that have highly rural populations might have longer commute times because you have to drive farther. I don't know. That at the same time, I'm sure if you're just looking at metropolitan area, then commute times are kind of more variable, and they probably depend on population density one way or another. And I'm not even sure what I think those relationships might look like. So I just want to explore and see what this looks like. And right now, at this level of spatial aggregation, I want to point out a couple things. First, notice it's telling me what data set I'm comparing. Here on the left, I'm comparing the 5-year estimates culminating in 2017. On the right, I'm looking at the 2019 one-year estimate. Now, if I want to compare apples to apples, I probably should change the data and find the same version of the data set, so that, or of the same wave of observation, so that I'm really seeing these things at the same point in time. And to do that, I would just say change data, and here I'd find data source, and you'll notice here as I scroll down right now I'm looking at the 1-year estimate, and there's the 5-year, and if I scroll down I'll get to 2017. I'll find it eventually, and I can limit it by year. So I could just say I want to look at the 2017 5-year estimate. And then I think that's what we're looking at. Ah, it didn't change. Anyway, I have to go back and change it. You can figure that part out. So in this assignment, what I'm asking you to do is find two different measures, compare them. Things to consider. Well, how are these classified? Right now, I'm not sure when I observe this. What am I seeing? So states with pretty good sized populations like California and Illinois and Georgia, Virginia, some East Coast states have really high commute times. So does Washington. What would that tell me? Probably states with highly urban populations have higher commute times. So New Jersey looks like it's pretty high. And if I zoom in, I can probably see that Massachusetts is too, and Maryland, Virginia, probably largely determined by DC. And so one question you might want to ask is, how are these data being classified? So if I adjust it, here I can change the cut points and analyze how this is being broken down and control it. So 11 classes makes it hard for me to read. And I'm going to work with an interval or a classification method that I understand mathematically at first, equal interval, because it does a good job of showing how things break down in an uneven distribution. Let me click on this again and tell you what I mean by that. So if I look at these cut points, I'm looking at the histogram here. Well, I've got one state, or excuse me, one county. What am I looking at? I'm looking at states. Yeah, so one state with much higher commute times than others. That is well reflected in an equal interval scale. This is something we talked about when we were talking about classification and classification schemes. You can return to that voice thread if you want to hear more about it or think more about it, or we can talk about it again. Here I'm representing this in an equal interval scale, which is telling me that New York and New Jersey look like they have much higher commute times than any other states. Probably what you would expect to see. Pennsylvania, Maryland, Virginia, they're all pretty high too. Massachusetts, California, and these rural states, so this is the opposite of what I was theorizing, is they don't have particularly large commute times compared to those more urban states. So right now it looks like population density and commute times might have some sort of strong correlation. You can kind of even see it in the map right now. The darkest states as symbolized are the ones with the highest commute times, for the most part. Not a perfect relationship, but there's some sort of correlation. Now, in the assignment, what we do then is we're going to look at this at multiple scales. So instead of looking at a state, I'm going to look at things by county. So now I'm looking at all the counties in the United States. It's kind of hard to see them all, so I'm going to pick one state. I'm going to click on this and mask the data, meaning I'm going to limit what I'm looking at to a single state. And I'm going to do that by clicking State, and then zooming into my beloved North Carolina and selecting it. And then I'll say Done. So that means I'm masking my results. I'm saying forget about those other states, I'm only interested in North Carolina. And now I'm going to say compare that side by side to the very same thing, except now I'm going to go find commute time. And if I want to do this again, I'll say side by side, and now I'll go to North Carolina and I'll say by tract, and then I'll add a mask, and I'm going to mask this to subgeography. I want to limit it to the county level if I can. Anyway, I'm going to zoom into my home county, Mecklenburg County, North Carolina, and look at this pattern there by itself. And then I can zoom in more closely to the place where I grew up, just outside of Charlotte, North Carolina, and take a look at the patterns that I might see at an even more local level. Now what I'm looking for, I'm looking to see if these correlations hold up over space. The easiest relationships to assess are going to be counties nested in states, states nested in the lower 48, and tracts nested in counties, or possibly other regions that you can define, a set of counties. We can talk about how to make those selections, but you can kind of see how we're going to build these stories. And eventually, if you have questions about masking particular regions or addressing this at particular scales, we can talk about that. So if you have questions about how to make these selections, about which variables to look at, that's the purpose of our next voice thread, in which I'm asking you to generate some visualizations, at least one, and post it so that we can discuss your own process of thinking this through. And then ultimately, what I want to point out is, in this story, when you're done, you can export this as a PowerPoint. So you can send this, you can upload this story when you're done with it and present it on VoiceThread as your own